Hello, welcome to the third week of Scalable Machine Learning. From this week, we will start to look at particular machine learning algorithms that are developed in a scalable way for big data. And we will look at several very interesting applications. And this week, we will start with scalable matrix factorization for collaborative filtering in recommender systems. So we will first look at what is a recommender system, and then we look at the most popular way of collaborative filtering. And then thirdly, we will study the matrix factorization approach for collaborative filtering. And finally, we take a look at how scalable collaborative filtering is implemented in Spark. So let's start with recommender systems. In our real life, we have many decisions to make. For example, to decide which mobile phone to buy and where to spend our holidays when we can, and if at home, what movie to watch when we want to have some fun. And to make such decisions, we often ask for recommendations. And it's not surprising that recommendations are everywhere. On Amazon, when we search certain items, we can see the recommendations of those frequently bought together based on purchasing history or based on viewing or browsing history, right? So customers who viewed this item also viewed, right? So this is a typical recommender system. And in Google, if you search, when you do a search query, and if you type in job, you will see a list of suggested or recommended search queries, right? So it's very popular, and you can see it's also localized, say in job in Sheffield. And on LinkedIn, if we click our network button, we can see they will recommend online events to me and also suggest people that I may know and want to connect it. So these are all recommender systems, and it's very popular and it's almost everywhere. So recommender systems are very important part of our daily life. And what recommender systems do is to predict the relevant items for a user in a given context. And not just a list of items, but it also aims to predict to what extent these items are relevant, because there are so many and you can only show a few. And therefore, recommender systems are doing a ranking task, right? So it's also kind of searching, right? So it's more automated searching for the user. And it is actually an implicit and targeted, which also means personalized, intelligent advertisement. And therefore, it becomes a very effective and popular marketing tool. There are two classes of recommender systems. One is called content-based recommender systems, where the systems recommend items based on the content. And the second class is called collaborative filtering recommender systems. It examines the similarities between the users for recommendation. So let's take a little bit more detailed look at the content-based recommender system. In content-based recommender system, the user will indicate interest to certain items, and then these items will be analyzed to extract feature values based on their content. And this will be used to build a user profile. This profile will be associated with the particular user. And in those candidate item database, each item will have a set of feature values. So they will have a content profile. And this profile will be matched against the user profile so that the content with similar feature values will be recommended. But this will become difficult when the items are difficult to extract feature values. For example, videos, music, or purchasing history products is difficult to extract the feature values and build the profiles. Therefore, collaborative filtering becomes very popular, and it works in a quite daily life way. Right? So that is basically for example, if one user bought some pizza and salad, and another user bought the same pizza, salad, and also a Coke, then based on the items they have already purchased, which is pizza and salad, it looks like they are quite similar. Therefore, we can recommend the Coke bought by the second user to the first user, and highly likely this will be a good recommendation. So this way is called collaborative filtering. And it just look at the items without analyzing the actual content. And in the next section, we will look at collaborative filtering.